So welcome dear learners in week 6 of Introduction to Electric Vehicle and Hybrid Electric Vehicle. And in today's lecture we will discuss about the battery technologies for EV. In the previous lecture we have seen different propulsion system and its components. Also we have seen the various power electronic converter associated in electric propulsion system. And we have seen various electronic control unit and controllers. So in this particular lecture we will see what are the various battery technologies are available for EV. Also we will see the fundamental of lithium ion battery, and we will see how lithium ion battery cells are connected in series and parallel manner, and we will see how those series and parallel combinations are used to making a battery pack. And at the end we will see what are the various design consideration for EV battery packs. So let us start with battery. As you can see in this particular picture, the lithium ion battery are used from the watt hour level to the megawatt hour level. No doubt this watt hour level is applicable for the small devices such as your monitor, your laptop, your washing machines. However, the kilowatt range is applicable for the EV like your two-wheeler, three-wheeler and four-wheeler application. And at the end this megawatt level is exclusively used for the renewable energy application. So battery is everywhere. Now in this particular picture we can see the evaluation of lithium ion battery. How these batteries evolve we can see using this particular picture. So the lithium ion batteries are introduced in 1991. Earlier it was used for the small devices such as mobile and wearable devices, but now it has been extensively used for electric vehicles, drones and various other applications, and because of its energy capacity. And in future this can be used for the aircraft as well. So this is the evolution of lithium ion battery. So why this lithium ion battery are more popular? As you can see in this particular picture, where power energy relationship for various energy storage devices are compared, and you can see with respect to the cost, compactness and other consideration, the lithium ion battery are more preferable over other types of battery. And why this one is preferable? Because lithium is the smallest metal, the first one. The second one is the lithium can release as well as accept electrons, and it is having the high energy density. So those are the things which makes lithium ion battery more preferable compared to other any battery packs. So let us understand how this lithium ion battery works. Lithium ion batteries are rechargeable batteries that store and release electrical energy by moving lithium ions between positive and negative electrodes. As you can see in this particular picture, these electrons are moving. The lithium ions move through an electrolyte which is situated between these electrodes, and it is a conductive medium that's typically a lithium salt dissolved in a solvent. During discharge of these lithium ion battery packs, the lithium ions move from negative electrodes, that is a anode one, to the positive electrode, that is a cathode one, while during charging lithium ions move back to the anode. So in this way this lithium ion battery packs works. As lithium ion moves, they create free electrons in the anode, which creates a charge at the positive current collector. So in this way this lithium ion battery packs work. Let us understand what is the discharge profile of the lithium ion battery. As you can see in this particular graph, the graph is plotted between voltage and charge depleted. As we know, there are 5 different reasons in the lithium ion battery discharge profile. The first stage, the first breakdown is known as initial voltage drop. During this region, the voltage is decreased once load is connected into the battery pack. It is a very it is a sudden drop, we can say. As you can see in the graph, it is dropped from 3.3 to about 3.1 approximately, we can say. After that we will get the stable voltage plateau. This voltage stable plateau, in this particular region we will get a smallest change in voltage with respect to the load. and this is what we call the working region of the lithium ion battery pack. After the completion of stable voltage plateau, we will have a gradual voltage drop in this particular region, okay, and then we have a rapid voltage decline this region, and at the end we will have a end of discharge voltage. So as far as our working is concerned, the stable voltage plateau is our matter of concern. So this is the stable voltage region. So whenever we are designing a battery pack using a lithium ion battery cells, then we have to consider this stable voltage plateau. Now let us understand what types of battery cells are available in lithium ion battery. So there are three major, or we can say three popular battery cells. The first construction is known as pouch cell, the second one is known as cylindrical cell, and third one is known as prismatic cell. No doubt energy density is increasing from pouch cell to prismatic cell. So depending upon your application, you can select any of those cells. Let us understand the comparison between the three types of battery cells. Okay, so here the three battery cells are compared on the basis of various features. Let us understand with respect to the energy density. With respect to energy density, the cylindrical cells are better with respect to the pouch cell. However, prismatic cells having the better energy density with respect to other battery cells. If we compare with the size, then cylindrical cell having the best what we call this size among all battery cells. And with respect to cost, no doubt cylindrical cell having the cheaper one compared to other one. And with respect to profile, the prismatic having the better profile. And if we compare the weight, then the best weight is pouch cell. However, pouch cell are mostly applicable for the small devices, or what we call the consumer electronics. It is applicable for consumer electronics. And if we compare the efficiency, then again pouch cell are more dominating compared to other one. However, with respect to power, if we demand more power, then prismatic is the first choice. However, whenever the efficiency is your first choice, then pouch cell is the preferable one. Let us understand some of the useful definition associated with lithium ion battery. The first definition is ampere hour, a unit of electric charge that measure a battery capacity. It indicates how much current a battery can supply over a specific period. For example, 2Ah battery can theoretically deliver 2 amperes for 1 hour, or we can say 1 ampere for 2 hours. So this is the H rating. The second one is the C rate, a measure of rate at which battery is discharged or charged relatively to its capacity. For example, 1 C discharge rate means battery is discharged in 1 hour, whereas 0.5 C rates means discharged in 2 hours. High C rate can affect the battery lifespan. The next one is the cycle life, number of charged and discharge cycle of a battery can undergo before its capacity falls to a specific percentage of its capacity, usually 80%. So it is this particular life cycle gives the battery longevity. The next parameter is the depth of discharge, the percentage of battery's capacity that has been used. A higher DOD indicates a greater level of discharge. For example, if a battery with 100 Ah capacity is discharged to a 20 Ah, which means its depth of discharge is 80% only. The next parameter is the nominal voltage. The average voltage a battery provides during discharge cycle is known as nominal voltage. For most of the lithium ion battery cells, the typical value of nominal voltage is 3.7 volt. Through the actual voltage range from about 4.2 when it is fully charged to about 3 volt when it is fully discharged. The next one is the charge voltage. A voltage at which the battery is discharged is known as charge voltage. The next parameter is the discharge voltage. A voltage at which battery is discharged is known as discharge voltage. And the next parameter is the state of charge. More commonly it is known as SOC, a measure of current charge level of a battery relative to its capacity expressed as a percentage. A SOC of 100% means battery is fully charged, whereas 0% SOC indicates it is fully discharged. The next parameter is the state of health. More commonly it is known as SOH, an indicator of battery current condition compared to its original states. It takes into account factors such as capacity degradation and internal resistance. The next parameter is the internal resistance, the resistance within the battery that opposes the flow of current is known as internal resistance of the battery. For the better performance of the battery, the internal resistance should be very minimal. Overcharge protection, a safety feature that prevents the battery from being charged beyond its maximum voltage limit is known as over voltage charge protection. The next protection is the over discharge protection, a safety mechanism that prevents a battery from discharging below its minimum voltage threshold is known as over discharge protection. So let us understand what is lithium ion battery packs. The lithium ion battery packs is a combination of various what we call the lithium ion battery cells. It may be a cylindrical battery cells or a prismatic battery cells. So it is connected, sometime it is connected in series and sometime it is connected in parallel. Okay, so we will in the next slide we will see how we can connect the battery cells. But in this particular picture we can see that how this actual lithium ion battery packs are looking like. As you can see, there are multiple part of this battery packs. The core part is the battery cells. The next one is the battery cell holders, which holds the battery so that it cannot affect during the operation. The next one is the outer casing. Sometimes it is the plastic, hard plastic make cover is casing is used, but for important application the cast iron is used to make this particular casing. Then we have lead and terminals at the front of the battery packs, which is used to collect the current, and sometime what we call depending upon the customer requirement, we use the MCB, DC MCB as well to provide the protection against the high current, what we call this during the short circuit it can be used. Okay, and the next important part is the BMS, battery management system. It is an inherent part of any battery packs, and we will have a what we call the battery cell connector as well inside the battery packs. Also there are other what we call the other component as well in the battery pack, like a valve, which is used whenever any kind of what we call the mal operation, or we can say any hazardous operation is going on inside the battery pack. At that time valve will be used. So depending upon the customer requirement and application, the size and the capacity of the battery packs can be made. And no doubt for the telecom application it is used in a rack. So individual rack can have multiple battery packs, and whenever we require the high voltage operation, we will connect different battery packs in a series manner to get the high voltage. So let us understand different types of battery for EV. As you can see, there are two batteries are more dominating in the case of electric vehicle. The first one is the cylindrical battery cell, and next one is the prismatic battery cell, just because of its capacity and its compactness with respect to other battery technologies. So let us understand how the lithium ion battery cells are connected in series. Whenever we require a higher voltage, then we connect the different types of battery cells in a series manner. Okay, so individual battery is not capable to provide a high voltage, and which is insufficient in majority of the application. So we require a series connection of the battery in order to get the required voltage. As you can see in this particular figure, the four battery packs are connected in a series manner. So whenever the battery cells are connected in a series manner, then the voltage is add up. That means if we are having the 4 battery in a series, the total voltage across the battery packs will be equal to 4 into voltage of one battery cell. So in this case we are having 4 battery cells. So you will get 4 into 3.6 volt across the battery pack. So in the case of series battery cell connection, the internal resistances are increased, and no doubt the capacity will be remain same. Suppose you are using 100 Ah battery cells, and if you are adding 100 Ah battery cells in a series manner, then no doubt its capacity will be remain same. That means if you are connecting 4 battery cells in a series manner, then the ultimate capacity of the battery pack will be 100 Ah only. However, the voltage will be increased. So depending upon your requirement, you can make any type of voltage, like 12 volt, 24 volt, 36 volt, 48 volt, 60 volt and 72 volt. Those are the very standard voltages for EV operation. And similarly, we are having parallel connection of lithium-ion battery cells as well. If we want the constant voltage, but if you want to increase the current level, you need to connect all those battery cells in a parallel manner. As you can see in the figure, whenever we are connecting the battery cells in a parallel manner, then the capacity will be increased, and also we can reduce the internal resistances, and we can increase the what we call the current capacity. However, voltage will be remain same across the connected battery cells. So here 4 battery cells are connected. As you can see, we can have the capacity total Ah capacity is equal to 4 into the capacity of one cell. So in this way we can enhance the battery capacity of the pack. So in this way we can connect series and parallel manner. However, sometimes we require series and parallel combination both. In some cases, like in high voltage operation, where we need to connect the different types of battery packs in a series manner in order to get the more voltage. Let us understand the different guideline associated for the let us understand the EV battery design principle. Whenever we are designing the EV battery, we have to consider certain points. The first point is the performance, and second point is the cost. No doubt, to get the better performance, we have to pay more, and if you are a cost concern, then you need to compromise with some of the performance. So always there is a trade-off between performance and cost. So if you are targeting the performance, then you have to ensure the crash safety, vibration isolation, thermal runaway prevention, cooling efficiency, and different types of other factor like quality and your comfort, and those are the parameters which are associated with the performance. However, if you are cost concerned, then no doubt your focus will be more on the speed of manufacturing, and you are trying to reduce the cost of the overall battery packs. And next one is the sustainability, and next one is the weight and size reduction. So there are various methods, like in some of the cases where vibration is more, we are using the flexible connectors in battery packs to connect two different cells. However, its cost is very high because flexible connectors are very costly. So depending upon your application, you have to select the some other component as well instead of using the standard one. So it is totally depend upon your performance and your cost. So in general, there is a trade-off between performance and cost. So let us see the current growth trend in EV battery technologies. The blade battery technologies are more preferable compared to the existing one, just because of its compactness with respect to the prismatic and cylindrical battery cells. So this type of battery are nowadays are getting more attention just because of its cost and its compactness. So whenever you are designing any kind of battery, then the space is the major concern, because if the battery is taking less space, then no doubt it will impact the cost. Also, it will impact the mileage of EV. Okay, so blade type battery is more preferable if you are considering the space and the cost. So in this particular, you can see the typical picture of a standard EV batteries assembly. It contains various battery packs along with its cooling mechanism. No doubt, this battery is connected across a power electronic converter, which converts this voltage into a standard voltage of what we call the drivetrain systems. So let us see the various advantages are associated with lithium ion battery. High charge density. Since lithium is the most electropositive element, it has high charge density and can give a lot of energy without being very heavy. This means this can store significant amount of charge for their size and weight. So nowadays lithium ion battery packs are extensively used for EV just because of this reason only, and in future as well it will be used for other application, for it will be used for buses and for truck as well. Compact design is one of the important advantages of lithium ion battery packs. If we consider the conventional lead acid battery, so it can store the charge in a very small package. So and because of that you can reduce the size of EV, okay, and you will accommodate more battery cells in order to get the more mileage of EV in a single charge. Low self discharge rate. If we compare lithium ion battery pack with respect to the what we call the lead acid battery pack, it is having the less self discharge. If you keep lithium ion battery pack as it is, it will not discharge for a longer time. So it is one of the advantages if you are using such kind of battery in your EV. So whenever your EV is in a standstill condition, then it will not impact the overall mileage of the what we call the car. Okay, and next one is the high scale current. Like if we can draw, like practically if you are having the 100 Ah capacity battery, then it can release up to 100 ampere current in a single battery cell. So you can imagine how much current it can be released. So for high current application, no doubt the lithium ion battery pack is a preferable choice just because of its current delivering capability. And next one is the free from toxic material. Compared to the lead acid battery, it doesn't have any kind of what we call the toxic material such as nickel and cadmium, which are associated with the conventional lead acid batteries. So it is free from toxic material, so it will not pollute our environment as well. So let us see the EV battery design principle. The battery module comprises numerous cells arranged in uniform distance from each other to provide efficient cooling and prevent from the occurrence of overheating. Electric vehicle battery packs consist of several battery cells. Okay, so as I have already described that EV battery packs are comprising various types of cells, like it may be a cylindrical cell or prismatic cell. A modular structure is necessary due to the electrochemical characteristic of the element. The cells are arranged in a stacked configuration utilizing a metal or a plastic support structure to accommodate the swelling that occurs depending upon the level of charge. The structure is commonly reinforced by attaching cells together or enclosing them within the metallic framework. The design guideline for electric vehicle batteries can often be a subject of controversy. The structure should prioritize being both lightweight and durable. This can be achieved by utilizing the lightweight metal alloys or carbon fiber material. Due to the strict guideline and standards, safety standards for the end product, the design and manufacturing procedures for battery packs manufacturer must balance the simplicity and accuracy. This particular figure illustrates the conflicting needs that impact the design process, serving as an example of existing solution. The requirements placed on the batteries varies depending on their intended use, but it is crucial to prioritize a structural integrity to ensure thermal stability and safety throughout the operation. Slide number 19, blade cell technology. As we all know, blade batteries are actually lithium iron phosphate batteries in essence, which can be regarded as a process of lithium iron phosphate. It still has a characteristic of high battery life of lithium iron phosphate batteries in winter. Because it looks like a blade, it named as a blade battery. Let us understand the different advantages and disadvantages of blade battery. Advantages of blade battery: flexible structure. The blade battery has flexible structure and the length of each battery can be customized to make full use of space in the car. Compared with ordinary lithium iron phosphate battery, the volume utilization of blade battery has increased by more than 50%, reaching the same level of power capacity of lithium batteries. High strength, just like a chopstick breaks, it would be folded, and branch of chopstick is difficult to break. Hundreds of blade cells with a length is less than the 1 meter are tightly arranged together, which are stronger and provide additional help to safety structure of the vehicle in event of a collision. So this is very with respect to the safety, the blade battery is better than the what we call the different other battery configuration like your cylindrical and prismatic. The range is close to the ternary lithium. At the same volume and quality, higher the power that battery can store, then we say that its volumetric energy density or mass energy density is higher, then the battery life of a new energy vehicle will be higher. The shortcomings of ordinary iron phosphate is energy density are made of for by a blade batteries. Longer battery life. As we all know that to measure the quality of a battery, we must also look at the life of the battery. That is number of times battery can charge and discharge, which is commonly known as the battery life cycle. At present, the lithium manganese acid batteries have the lowest number of battery cycle, and the lithium batteries are at center. Lithium iron phosphate battery has highest number of life cycles, as are the blade batteries are lithium iron phosphate batteries, so therefore its life cycle is pretty much good. Excellent safety performance. Puncture test, the surface temperature of the battery is 30 to 60 degrees Celsius, and it is not easy to spontaneous ignite. Now let us see the disadvantages of blade battery. The blade battery characteristics are relatively poor at low temperature, and it is still not resistant to low temperatures. This is an occupational disease of lithium iron phosphate, and the battery power will greatly reduce the cold winter condition. The second point, the maintenance cost is higher because the blade battery eliminates the need for the structure to support the battery cells and uses each battery cells itself as a bracket. Under the impact of external forces, it is difficult to ensure the integrity of the battery. One battery is damaged, and rest of the other batteries in series will also be affected. The manufacturing cost is higher side, and the process is difficult for making the blade batteries. So in this particular lecture, we have seen the fundamental and working of lithium ion battery packs, and also we have seen the discharge profile of lithium ion battery. Also we have seen the comparison of lithium ion battery cells, and we have seen the different types of connection are associated with lithium ion battery cells, and at the end we have seen what are the battery principles or what are the different. At the end we have seen the EV battery design principle in this particular lecture. So in the next lecture we will see the fundamental of battery management system. Also we will see what are the functions of the BMS, and we will see the different types of BMS available, and we will explore what are the different structures are associated with BMS, and we will also see what are the various research trends in the BMS. So these are the references that I have used for this particular lecture. You can go through these references for more detail. Thank you so much.